where I'm going to present our integrated battery sensor project. And we are a sensor technology company where we have the vision to accelerate the transition to fossil-free energy through disruptive sensor technology, where we basically are using a fiber-based sensors that can go inside the battery cell and largely improve the performance of battery energy storages. Because that's something we all know that needs to change. We have increased amount of renewable energy coming in, but to get this rolling a lot faster, we need to be able to store it, because the sun doesn't always shine and the wind isn't always blowing. Battery is a key technology in this, and to increase the performance of batteries would simply help this transition to happen, both on the storage side and also on the automotive side. If we can improve and get the batteries cheaper, better performing, and also remove some of the safety risks, we can speed everything up. And a heck of a lot of money goes into battery research, but it goes in two separate silos. We have a lot of money going into building gigafactories and developing the different chemistry and the different way of building the battery cell. And we have also a heck of a lot of money going into developing algorithms and making the electronic parts work better. But it still doesn't really work. We still have the same problem as we can experience with our cell phones, also in bigger batteries, that the battery can go from 20% to dead in a few minutes because the measuring doesn't work. And it's because of this information gap, and that's where we come in. So we are truly disruptive in that way, that we have a technology that can become small enough and robust enough so that it can go inside the battery cell with its fiber sensor and bring the information of what's going on there to the electronic system. And doing that makes it possible to increase the working space of the battery, so that we doesn't go down to 25% to be on the safe side and up to 75% to be on the safe side, but actually use a lot more of the battery without harming it. Increasing the energy, reducing the cost per battery, and prolong the lifetime. And that is the technology that we think we can have as a start when forming a long-term relationship with ABB, to basically improve and give a competitive advantage for the battery energy storage solutions that ABB is providing. But in the long run, we are a sensor technology, but we need a system with the sensor inside. And ABB is a big company that has a huge system. And we also see that we can take it further to transform the whole battery market. So with our project, we want to get our sensor inside and perform tests and prove that this is actually working. And from there, we can basically do the market study, do the tests, and see that it works well. And with that in hand, we have a good scaling possibility together with ABB, where we can do the initial tests on microgrid, where we have a collaboration with small battery companies, but where when growing to microgrids in growth scale and going up to grid, we as a small company need this collaboration to also bring in the bigger cell manufacturers that is needed. So that's the way that we see it, that we can improve the power flow solutions provided by ABB, reducing the battery cost, prolong the battery life, and basically increase sales. And for us, we get a good negotiation power when talking to the battery cell manufacturers. We get our sensor in a system, and we get access to global customers, which increase our sales, so that we together can get more battery energy storage out there, get faster turnover to the transition to fossil-free energy, and earn some cash. Questions on that?
Okay, thank you very much. I'm just wondering about competitors and why you are better than them.
There are other competitors that see this problem to basically get more information into the steering system, the battery management system. But so far, no one has proved or been able or maybe dared to go out inside the battery cell. So the other competitors or the new technologies coming up are looking at pressure changes or temperature changes, but still outside the cell. So there are other competition going up to try to solve this information gap. But as far as we see it so far, nobody is going the full length.
So can you tell us a little bit more about how you're actually integrating with the cells? And does that require you to have basically presence within the cell line for like an LG Chem or a BYD? I guess there's a further question. When you're actually putting a sensor into their cell, does that negate the warranty? We're pretty sensitive as consumers these days to lithium-ion battery explosions, fires, etc. Once you start sticking sensors into all these unit cells, it seems like there's going to be a lot of risk that pops up as a result of this increased telemetry.
Yeah, and this is basically the first type of questions that we got when we started this project. So what we have done with the smaller cell manufactured AGM batteries, a company based in UK, was basically to sort these things out, to bring because we need to go into the cell. But it's in the last line, in the last, so basically what the larger cell manufacturer needs to do is to add one more mounting table, basically place in our cell before sealing it and starting it. So it's not a big investment, but it needs to do a bit of testing just to secure this. But we have the testing done to see that we don't affect battery performance and that it can be sealed in a nice way. So these initial tests.
It's potted and you have a separate lead wire coming out. You have to
yes.
Cabling and everything.
It's very small optical fiber coming out in between of the two electrodes. So basically, in the same way that you get the electrodes out, when sealing that at the same time, you also seal it with our fiber inside. So it's just bringing it in the last step and then using the same sealing as you do when in standard manufacturing.
How do you see cost increasing?
That's one of the strengths of this technology, that it's scalable when it comes to bring it up. It's basically using optical fibers with nanoparticles and then LED lamp and various components.
Last question.
Yeah, same question as I did for the first one. I mean, thank you very much. It's really interesting, very, very interesting. I have surfed in your site as well, so it's not the only thing that you are doing. You are doing lots of very fun things as well. So my question is that in what way do you see that this project will affect your company in coming year? I mean, what's...
The battery sensor project is our main project. We come from the research where our university spin-off, so we started by using this technology, selling it as a research instrument and prove the technology. But we have always seen that it's much bigger potential applying it in specific applications. So when talking to Volvo about their needs and seeing that, yeah, this is a good fit, we started to head in this direction. So even though we are working with 3 projects, the battery sensor is the main, then we're also looking at air quality and our research instruments. That's correct.
Thank you so much.
Thank you.
Thanks.